Hi, I'm an old guy and I do maths. And today we're looking at how we graph y equals tan 2x. Now, the position of the number 2 here indicates that there is an alteration in the period of this graph. Now, just a quick reminder, I've drawn a small version of a normal tangent graph here, if you can call tangent graphs normal. They're fairly strange. Now, this has asymptotes at pi on 2 and 3 pi on 2, 90 degrees and 270 degrees, between 0 and 2 pi, between 0 and 360 degrees, and it looks like this. Now, what we are going to be doing is we're going to be altering the period of such a graph, and we do so by inserting a value here that is other than 1. Now, how we calculate the period of a tangent is different to how we calculate the period of a sine or a cosine graph. The formula for the period of a tangent graph is pi on n, and this value here is n. So in this case, the period of this graph is going to be pi on 2. Now, without making you too dizzy, if I move down the page, this is a full cycle of a tangent graph here, and the difference between pi on 2 and 3 pi on 2, this distance here between these 2 points is pi. So the effect of making the period pi on 2 is going to be that the asymptotes come closer together. And so the asymptote that would normally have been at pi on 2 is now at pi on 4. The distance is halved. So I'm just going to draw this in. Excuse me for doing it freehand. And our graph is going to start looking like this. Now, the next asymptote, and I hope I can do this to scale, the next asymptote is, instead of being at 3 pi on 2, is going to be at 3 pi on 4. Now, hopefully you can get yes, we've got all of that in frame, and you can see what's happening. Basically, because the period has been halved, the denominators of these values has doubled. And that's a really good, fast way of working out what will happen to the asymptotes. If the period is halved, this is doubled. If it's divided by 3, this is tripled. If it's extended, then this number gets smaller. Okay, so just draw this in, and this is a point at which I can show you the length of the period here. The length of the period is the difference between 3 pi on 4 and pi on 4. So the difference between 3/4 and 1/4, which is pi on 2. Please note that it is half of that. Our next asymptote will be here, and we'll get a full cycle in here. And this point here will be 1 pi greater than this. Sorry, it'll be pi on 2, I beg your pardon, greater than this. So 3 pi on 4, let's do the maths up here. 3 pi on 4 plus pi on 2, which is the equivalent of 2 pi on 4, we'll do it this way, gives us 5 pi on 4. 5 pi on 4. So those of you who are into number patterns will notice something's going on here. This is pi on 4, this is 3 pi on 4, this is 5 pi on 4. The next one we're going to get, I'm going to have to extend this out a little bit. The next one we're going to get is here, and it's going to be 7 pi on 4. I hope you can see that in there. And there we are. And then 2 pi is out here, and so we have some vestigial bit of the graph down here. So just to summarize what has gone on, the effect of this is to halve the traditional period of a tangent graph from pi on 1 pi, to pi on 2. What that has the effect of doing is halving the distance between asymptotes. And it's a really good way to draw this, to work out where the asymptotes will be and then to fill in the graph. So if we look at this graph down here, pi on 2 has become pi on 4. It's halved. The distance between these is no longer pi, it is pi on 2. And 3 pi on 2 has become 3 pi on 4. Add pi on 2 to that and you get 5 pi on 4. Add pi on 2 to that and you get 7 pi on 4. There is a pattern that you will see repeating when you do this. Anyway, that is how you graph the function y equals tan 2x between 0 and 2 pi. And that's the difference that you see between it and the standard tangent function y equals the tan of x. I hope this was useful. If it was, please like and subscribe, and I'll see you next time. Bye.